I want to think about this idea of how all these different concepts are involved, right? And I said that there's no new concepts. Okay? The tricky part is trying to understand which probability principles you're using when, right? Let's just go back to this simple example. When I looked at the probability of drawing cards from a deck, right? If I said the probability that I draw either a spade or a heart, what do I really mean there? What am I really saying?
It can be 26 out of 50.
How did you get 26?
13 plus 13.
See, intuitively, right? You've seen this word here, or, and you've thought add. And that's exactly right. If I say P of A or B, really what you're saying is P of A plus P of B. Now, this only works when they're mutually exclusive.
Wouldn't A and B mean the same thing
Sorry.
as well?
Yeah, mutually exclusive.
A is spade and B is heart.
Yeah. So, for example, the probability of the spade you said was 13 over 52, and the probability of the heart is also
13 over 50.
And you put them together, you're right, you get 26 over 52. Notice, though, that these are two separate cases.
Oh.
You can't have a spade and a heart at the same time.
What is that?
Right?
Mutually what?
Mutually exclusive. It means that they're separate, right? A spade can only be a spade and a heart can only be a heart. There's no overlaps there, okay? That's the first principle of tree. That we can use addition to calculate probabilities when we see the word or. The tricky thing is when we see the word and.
Both of them.
Because there's a very subtle different meaning. When you think about it in terms of a language perspective, or and are very similar, I guess, right? Like Jesse or Nathan, or like Nathan and Jesse.
You have to
But-
put both out of the bag.
Right, yeah, and that doesn't seem to really make sense when we're drawing cards. It can in certain circumstances, but I want to go back to the coin flipping example.
Definite.
I want to go back to the coin flipping example, right? When I talked about flipping a heads and a heads, okay, after each other, do you remember what the probability of that
1 in
was?
4.
1 over 4. The way we get that is we use the multiplication
Double it.
principle, right? So I say, well, we don't double it because
It's a
double
series,
half,
really.
double of half would be
A
1.
or A
Yeah.
Yeah, it's a series.
So if I see and in probability,
Oh, fine.
this is going to be P of A times P of B. Now, if we go back to the flipping the heads example, right? I already know that probability of flipping heads is half. This case here, right? In this case, if I want to find the probability of flipping 2 heads, what am I going to do? I'll just do half times half, which should equal to 1 over 4. 1 over 4.
What happens if
That's
they
the
have
probability
different
of flipping
denominators?
2 heads. That's fine. We can still multiply them.
They still do the same?
You
Yeah.
guys
Still
just
do
Cross
change-
multiplication level.
Or you just multiply across the numerator, across the denominator, right? Now, let me just rephrase here, right? Let me just rephrase. All I've done here is show you two kind of examples. We have something called the addition rule or addition principle, but we also have something called the multiplication principle. And it's important you know which ones to use when. Those or and ands can be an indicator, but they won't always give you those words. I said something in particular about coin flipping that was unique to it. I said that they were independent events. Do you guys remember me talking about that?
Yeah, just one at a time.
Right. I said that when I flip a coin, right, because a coin doesn't have memory, all the previous results, they aren't affected. They don't affect the future ones, right? And this multiplication rule can only be used when the events are independent.
So it's not like blackjack, which would be addition because like playing blackjack because all the cards are being used.
I will talk about those kinds of examples later. But don't overcomplicate it here, right? All I'm presenting to you are two scenarios here, right?
Yeah.
Addition, so if I see or, I'm thinking addition. If I see and, I'm thinking multiplication. But I just want to note, are the events independent? Right? Will something affect the other? And in the case of coin flipping, I know that it won't.